Wikipedia, our best or sometimes worst source of ready-to-use information, says under rheology that the word is, of course, of Greek origins and that it's composed of the root rheo, R-E-O, that means to flow, and of the suffix logia, that instead comes from the word logos, that can be translated as speech, expression, theory. Okay, Wikipedia also said that rheology is the science that deals with the deformation and flow of materials, primarily in a fluid state, liquid or gas, under conditions in which they respond with plastic flow rather than deforming elastically in response to an applied force. It is a cross point between biology, chemistry, physics, mathematics, engineering, and biology. And since in our podcast we use the word rheology very often, we should make an entire episode about it, but it would be very complex and maybe too technical. So this is the reason why we only say that, put it simple, in our case, and so in ceramic, rheological values define the features of all fluids involved in the ceramic production process, such as slurries, smaltobbi, grit, or glaze suspensions. So, the keywords of today's podcast are glaze, rheology, and application systems. And after the theme song, I will tell you more. I am Davide Trentini, and this is Apparently Invisible: Chemistry in Ceramics. Today, we go back to some topics that we have already shortly addressed in a previous episode. I think it was the one about the main categories of chemicals for ceramic glazes, but that today we would like to deepen. Of course, you can go back on our app or on the main platforms if you want to listen to the episode again. And because at that time we talked about the most important features of each category, pointing out their actions and the mechanism behind that actions. Today, instead, even if we're still talking about glazes, we will focus on the different rheological features that each glaze must have according to the application systems, whatever is Bell, Vela, or spray system. In fact, as you surely know, each systems require different features. Once we have offered an overview about this topic, we will end with a short focus on a special family of chemicals, that is, synthetic chemicals. But let's go step by step, starting from Vela and Bell application systems that today are not very common, but that are still in use in several ceramic companies. Here we put them together because the glaze applied with these two systems must be marked, more or less, by the same features. Of course, I want to start with a recommendation that I usually remind you, and that is that the number of scenarios is very huge. And this is why I underline that the suggestions that I'm going to give you are examples that allows you to make some important distinction, knowing that any single case must be managed according to the specific parameters of the production line. This is, for me, is a sort of a mantra because, as I always say, a universal solution does not exist, especially in ceramics production. That said, we can surely say that glazes applied by means of Vela or Bell systems usually require chemicals able to reach a high density, such as 1,700/1,800 grams per liter at 25 degrees. What does that mean? Let's try to translate this sentence. First of all, the sentence says that the density value may change according to the temperature. In fact, we said at 25 degrees. And this is because density is a volumetric measurement, so the liquid can modify its volume based on the temperature. Okay, but what about 1,700 and 1,800 grams per liter? What does that mean? These numbers define the weight of a liter of glaze, and of course, the greater is the weight, the higher is the density. We can now add that beside the high density, all glazes applied by means of Vela and Bell systems should be mixed with chemicals able to provide the system with a high cohesion, promoting a homogeneous discharge of the glaze on the raw ceramic support. And this usually means working with high levels of fluidization, using CMC marked by a medium or high viscosity value, and choosing properly the dosage in order to promote a drying process that is suitable for multiple applications. That is, an application of engob and glaze by means of two applications machines, both bells or vela systems. I try to better explain this last statement. The engob applied by the first machine must properly dry on the support before the tile reaches the second machine that discharges the glazes. And this is very important to ensure the best integration between the two overlapped layers. Things would be different in case of an application of smaltobbio, of course, but I stop here because now I want to talk about the most common application system. That is, the spray application system that usually requires chemicals able to provide the glaze with low or medium-low values of viscosity and density. For example, about 1,400 grams per liter at 25 degrees. Why? To avoid possible sedimentation phenomena within the glaze or to avoid lack of cohesion between the particles, it would be important to work with glazes not too much fluidized, choosing a CMC marked by viscosity values suitable to reach a proper leveling according to the glaze in use and the temperature of the tile. What does that mean? Let's try to explain it better, or in any case to give you some more info. CMC, that is polymers of carboxymethylcellulose, can be marked by very different features, and this is the reason why it is very important to choose them according to the characteristics of the glaze involved in the process. For example, in case of a very plastic glaze that is marked by high cohesion and viscosity values, it would be better to use a CMC marked by a low viscosity value or, as an alternative, to lower the dosage. On the other hand, a low plastic glaze that is poor in clay would require CMC with a higher viscosity value to ensure a good cohesion and a proper drying process on the tile. But what about the temperature? In general, we can say that both the selected CMC and the dosage can affect the drainage and the evaporation times of the water of the glaze suspension. This is why the temperature of the ceramic support on which the glaze is discharged, we are basically talking about operating temperatures, is a very important parameter that must be considered when choosing the CMC. That said, I would like to add that in case of airless spray application, together with CMC, other kind of chemicals must be usually added. What are these chemicals? Well, for example, leveling agents, or in case of glaze application after the digital printing process, of compatibilizers that match the different chemical natures of solvent-based inks and water-based glazes. In general, it is also a must the use of one or more binders, both during and after the grinding process, to provide the glaze with the right cohesion, proper rheology values, and a good binding power between the glaze particle. These parameters are essential to avoid the so-called dusting phenomena that usually arise due to the lack of cohesion. And in this regard, binders are able, of course, to increase the binding power of the glaze and its drying times, improving the leveling process on the support and avoiding the formation of non-standard drop of glaze, that is, too big drops that would negatively affect and compromise the tile. Good. Let's now introduce the final part of the episode by saying that if density, viscosity, and rheology values of the glaze can be always managed and adjusted according to the process parameter, the presence of microorganisms, and more specifically of bacteria, within the glaze, of course, is instead much more difficult to handle, especially because bacteria are detected only when unpleasant odors arise, that is, when the degradation is already underway. As we have already seen in one of the first episodes, bacteria do not produce only bad odors. They also negatively affect the action of binders, for example by decreasing or even nullifying their power. But there's more. The metabolic waste inside the glaze, produced by bacteria, may often lead to application problems and to technical or aesthetical defects of the tile that can be sometimes visible even after the firing process, such as, for example, pinholes. So, the question is, how to prevent and dealing with the problem? That means, how to restore the action of chemicals within the glaze suspension. Let's see the most important and useful action. One of the less invasive is to add the glaze along the glazing line with an additional amount of binder just before the application. However, even if this is usually useful to restore the features of the suspension, it is not enough sometimes to avoid post-firing defects. In addition, this kind of intervention must be rapidly developed since the degradation action promoted by bacteria is usually very, very fast. And this means that we should be aware of the problem exactly when it appears. And this, of course, is not very easy. A second action able to restore the features of the glaze is the addition of a huge amount of biocide. It is usually called the kill dose, to get rid of all microorganisms. But even if biocide protect and preserve the glaze, sometimes they are not strong enough to avoid tiles defect. And this is why, and here is the third action, it would be always recommended a real preventive action to develop when bacteria do not have attacked the glaze yet. The solution consists in adding the glaze during and or after the grinding stage with a proper mix of biocide and preservatives. However, this is a solution that in some cases it is difficult to put in practice since it is almost impossible to 100% check the presence of bacterial proliferation within all the production areas of the plant. So, if this is the scenario, what can we do to solve definitely the problem at the roots? What kind of magic should we use to face bacteria that are so good in affecting the glaze and the chemicals inside the glaze? Well, the magic, it simply consists in developing different and new categories of chemicals that cannot be attacked and affected by microorganisms. I know, it's simple to say, but not very simple to do. But you need to know that in this regard, R&D labs have been working on this topic for some time, and even if they are still researching for definitive solutions, some interesting results seem to be already very promising. And this is a new approach based on fully synthetic chemicals. It works very well, but of course it cannot exclude the presence of bacteria inside watery systems, but it can surely reduce and contain their proliferation. What is the main feature of these new products and why do they not degrade? Well, in general, as we said, all products of natural origin or natural modified origin such as CMC are usually a nourishment for microorganisms because of their molecular nature that can be easily degraded through many actions of biological nature. The use of synthetic molecules instead makes bacteria that, I repeated, can affect and destroy molecules of natural origin incapable of finding the way to develop their degradation process. I also want to clarify that the word synthetic refers in this case to single monomers or oligomers that have been properly managed to get new molecules that do not exist in nature. Okay, and this is the end of the episode. Here's a very simple example to clarify the difference between the two kinds of molecules. Think of a polymer or of a natural molecule as it was a wool yarn. Bacteria are provided with scissors, that is their mechanism of action, that cut the yarn in a lot of small pieces that can be easily eaten. Think instead of the synthetic molecule as it was a barbed wire that hampers bacteria, the scissors, remaining safe and active. And with this last suggestion between scissors and the yarn, our episode ends here. I would like to remind you once again that all the previous episodes are freely available not only on the main platform, but also together with many other contents on our app that you can download for free on Apple Store or Google Play. You just need to type ZNS Ceramco, Ceramco. See you soon.